Alright guys, so I want to talk about the main idea of function composition here. So remember that to do function compositions we got to know what a function is. So let's write down our function definition here. So a function is a set of inputs and outputs, where every input has only one output. Now remember that vertical line test, right? If you're on a graph, right, you should be able to draw a vertical line anywhere and you only hit once. If you have a graph of some relationship and it squiggles about and you can draw a vertical line and it crosses twice, this means it's not a function. Alright, but this one is a function. Right, because every input only has one output. That's going back to the idea of a function. Right, but function composition is a new idea. It's not something we can do with numbers, like I said yesterday. It's something unique to functions. And the big thing with functions is they have inputs. And so instead of just putting a number in a function, we can put a function into another function. So we can put function into another function. Or maybe said more correctly, we can put the output of another function as the input of a new function, right? So you can string along these outputs into inputs of functions. And we kind of drew a picture of this yesterday, right? We said like every output kind of looks like a black box. You have inputs somewhere, it spits outputs out. Right, and every function works like this. You put an input in, you get an output out, right? Some examples of functions that we see around us are like grocery store scanners. Right? You put in the barcode, once you scan it, it spits out a price. Right? You don't know how it's doing that. You don't need to know exactly the rules of the function. Right? How does it change all those black lines and white lines to make a price come up? But you know that it's going to work as a function, because no matter what they scan, if you scan it twice, you should get the same price for an item. Right? So you know it's a function. Right? So many ideas are like that in life. Right? And so functions have inputs and outputs. You don't need to know what happens in the middle. A lot of functions in math classes, we do know what happens in the middle because we often define functions as rules. So for instance, like f of x equaling x squared plus 2 is a function where the input is x and the output is whatever number we get after we square and then add 2. Now we're going back to function composition. So function composition takes two functions to happen. Right? So we have function f, maybe we have function g. Function g also has inputs, right? And it also has outputs. Right? But what we can do is, instead of just having this output be done with, we can just string it along into g, and then we can make this output equal to those inputs. And now we kind of can, instead of thinking about this as two functions, think about it as one big function, right? We can, instead of thinking about f and g individually, which we might do in order to figure out what inputs are going to give us specific outputs, but if I just wanted to put a container on this, not care about what happens in the middle, ignore the middle, this is now a new function composed of f and g, and in particular it's g composed with f of x. Right, is what this bigger new function is. Right? This is the idea of function composition. Instead of just having one input go to one output, we can think about an input becoming an output, becoming an input, becoming an output. Right? So you can string functions along, creating more and more complex functions from pretty simple functions. So in the next video we'll do a first example with this.